Today on Builder and Maker, we're going to be building this camp faucet for when your campsite does not have a water spigot. It's battery powered, so all you need to do is just hit a button. Now you might be thinking, I can just buy one of those. And to be honest, the one that Dometic makes, especially if you can find it on sale, is actually a reasonable price. Building it yourself actually will not save you a ton of money, but that's not what we're really about here. We like to build things, so why don't we build our own? So our goal is simple. We want to build a powered by a power tool battery, water pump that can pull from pretty much any water jug, whether it be the 1 gallon ones, 2 gallon ones, or any of the many portable, reusable ones that you can get at any camp store. My first thought is, this is really simple. Get a battery adapter, a voltage regulator to step down to the 12 volts that the pump needs, and package it all up into a 3D printed case with an on-off switch. Done. Easy. It's actually coming out pretty fast, so the idea will be that this whole thing will be sitting on top of the battery, and the battery will kind of be giving it weight so that it won't tip over, and then you've got a little camp faucet. So I threw that all together, and immediately I ran into the first issue. One thing I didn't think about when I started with this is that this voltage regulator is always powered. So I had messed with this a few days ago, tested it out, and didn't think about it, and now the battery is dead. So leaving it powered overnight actually killed the battery. Alright, so I think I pointed out that switching only the output on this leads to draining the battery. And I still forgot, and I did it again and killed another battery. So here's the new setup. It's a much smaller regulator because we actually don't need that much power. The input is switched, as you would expect. But I decided to do a test, and I left the input on and ran both of these. This one died, went to 0 from full charge in 24 hours. This one, after 48 hours, is still at half charge. So even if we didn't interrupt the input power, we still would be just fine with that one. It also helps because this voltage power supply is gigantic and really hard to fit, where this one's actually really easy to fit. So anyway, printing the final parts so that we can assemble it and test it out. That's actually part of why I use Ryobi batteries for this. Ryobi batteries have an internal voltage regulator, whereas some of the other ones like DeWalt do not. So if you drain a DeWalt, you may not be able to recharge it, but a Ryobi, if you drain it down to near 0, it actually cuts off the output voltage internally until you recharge it. So I rewired everything, put the switch in the right place, and I was done. Or so I thought. But then a friend made a little comment that changed everything. He said, wouldn't it be cool if you hit a button and you get like 15 seconds of water? And my initial thought was, yep, you're right. But that means that I have to put more than the absolute minimum effort into this. But really, we will get a much better product out of this. To pull this off, we need a brain. I have a ton of Arduinos laying around, so I grab one of those and get started. One of the fun things about having the Arduino in the loop here is, well, now we can use PWM to control the motor. And we can have speed control, flow control. We can even like calibrate it timed to pump out a single cup of water. So I've got now a button, an Arduino. We'll replace this with a Pro Mini, running into a little MOSFET to control the motor speed. So a single click runs it at medium speed. Another click turns it off. And then you've got a double click that'll run at low speed for 15 seconds. And it takes a little bit to fully prime, and then it comes out. You can interrupt it at any time with another click, turn it off. You've got a triple click to go at high speed for 15 seconds. If you really need to wash those dishes, interrupt at any point. Or I implemented a long click, which is just on continually at high speed. And then a normal click and it's off. Time to convert this prototype here and get it into the freshly printed body. For that, I'll be using these Pro Minis instead of the Uno, because the Uno is gigantic. So the Pro Mini has everything we need and nothing we don't need. It's nice and small. We'll probably just hot glue it in. All right. Let's grab a multimeter. There's our 12 volt. Okay, so the voltage regulator Didn't like the 12 volts. That's annoying. The voltage regulator on the board did not like the 12 volts, even though it says it can take in 12 volts. So I just pulled it off. In my random assortment, I have a 3-volt regulator, and it runs just fine on that. So let's get that soldered in line. Let's think about how we can do this. I think we might be able to do something crazy like bend the V-in pin up. So V-in pin bent up. It ruins my ability to reprogram it later, but I don't have to go and resolder all of this. And everybody's on. Let's see if the pump runs. And with a little hot glue, everything fits in the body. Let's go ahead and connect this, connect this. And here's a new thing I printed, kind of a filter. It'll keep big chunks out, but the big thing it does is when the tube hits the bottom and plugs completely, it just collapses. So what this does is it prevents that from ever happening. Perfect. And there you have it, a battery-powered, customizable, reprogrammable camp faucet to do kind of whatever you want. Overlanding, camping, whatever you really need it for. This project was fun to build and is actually a pretty good example where a little idea can go from a really simple project to not that much more complex, but significantly more functional. It's way more functional with the added modes. In the video description down below, I will put the Printables page with the models and the code, so you can build it yourself. And you saw throughout the whole thing that I was probably using a Ryobi battery, but it actually also works with DeWalt, so I'll have that and all the parts you need to order on the Printables page as well. So what do you think? Would you build one of these yourself? What power tools do you use? I added the support for the 2 power tool batteries I have, but it's really easy. I'll even upload a blank so you can actually remix it into whatever you need. If you enjoyed this build, please don't forget to give it a like and subscribe if you're interested in more maker projects and adventures.